So this is going to be the video for explaining the function generator and in general how to use this function generator. Function generator that we use, we have two of them, usually one out here in the T-space and one over in the experimental room, is a Siglet SDG 1032X. So in general, for most of the experiments we use this burst parameter. If the function generator hasn't been turned off, it'll automatically default to this. But if for some reason the function generator has been turned off, you'll see a screen that looks somewhat like this. It'll default to a sine wave. All the function generators have pre-stored functions to get it back to generally the experimental setup that we want to use. In order to get there, we're going to first go to this store recall button and press that. You'll see a screen like this pop up. Normally you'll see local files, which are not what we want for this case. Those are preloads. We want to change our file type down here to state. So once that's up, you'll see transducer 1, transducer 5, patch 1. That just refers to whether it's 1 or 5 megahertz. So we'll use our scroll wheel over here, scroll down to transducer 1, and then we'll press recall right here in the middle by pressing this button right here that says recall. And you see we've imported our general experimental file in here. We're under our burst functionality here, and we want to keep that button highlighted as always. So in general, this is a ready to go for the most part to just plug into the amplifier here and you'd be ready to go. We're set to 1 megahertz for our frequency, an amplitude of 100 millivolts. Offset doesn't really matter. Starting phase also doesn't matter for us. Positive polarity, that just means that the waveform will go up in the beginning compared to going down in the beginning if we have a negative polarity, and then our burst period here of 1 second. So let's say we wanted to turn this on now. I'm going to go over to parameter here. If we press that parameter button, we can see our highlighted value comes up here. So now we can change any of these 3 values up here. So I'm going to lower our amplitude down to 80 millivolts. You can do this one of 2 ways. So first way is you can manually input 80. So once this highlighted, whatever is highlighted in blue here, if I just press 80 on the screen, on the keyboard, it'll put it there. Now I need to specify the voltage. So we're going to do millivolts here, as we don't want to put 80 volts into our amplifier, and this function generator can only output 20 volts peak to peak. So we have our 80 millivolts peak to peak stated here, and then the other way to change this was to just move this dial. So we can see the whole value is highlighted in blue, but whatever decimal place is highlighted in white here is what this dial will change. So if I start to turn this clockwise, that will increase our value. So now we're seeing 82, 83, 84, but I can also bring it back down, 83, 82, 81, 80. And then if we use these arrows on either side, just underneath the dial, we can change the decimal place we're looking at. So now we're at 80, 90, 100. And I'm going to bring it back down, 100, 90, 80. So one of 2 ways to change that value. So now we have that set. Our frequency is at 1 megahertz because we have 1 megahertz transducer set up here. I'm going to take this cable. We're on channel 1 here, so channel 1 is green by this BNC connector, and channel 2 here is in yellow. So we're on channel 1 here. I'm going to press output. You know the output's on when this is highlighted with this backing green light, and then we're going to plug it into our amplifier. And we can see here now that we are plugged in. There's power going through our amplifier here, and we can also see over here on the function generator, this is covered in the oscilloscope. This functionality is covered in that video. Please refer there if you have questions on how to use that. But now we can see here we're reading a voltage. So that's good. This is the traditional values for a 1 second burst period with the polarity set to positive. That means we are at a 50% duty cycle for whatever this burst period is. So the duty cycle is the ratio of time on to time off. So if we're at 50%, we are on for 50% of the time and off for 50% of the time. For most of the experiments that are run in intensities, pressure intensities that are below approximately 300 to 400 kPa, 50% duty cycle is used for those. But at higher intensities, let's say in the megapascal intensities, so 1.2 megapascal, 1.5, a 1% duty cycle is used. So in order to change that, we're going to go back to our burst parameters here, so our burst button here. So we're on parameter right now, hence that it is highlighted. If we want to get back to burst, we're just going to press the burst button again. You can see that the parameter is no longer highlighted and only the burst, and our highlighted window is down here now. So right now we're on start phase, but we want to change the percentage of time that our function generator is on. So in order to do that, we're going to change this from a gated signal to a n cycle signal. That n cycle is number of cycles. In order to change that, we're just going to press the respective button just below it. You can see here now that we have a new parameter here named cycles. So with a 1 megahertz transducer over an entire second, that equates to 1,000,000 cycles per second. So with a 50% duty cycle, we have 500,000 cycles. But if we want to go down to a 1% duty cycle, that will be 10,000 cycles. Similarly to changing our amplitude, we can change the cycles in the similar ways of typing on this keyboard or using this dial. For simplicity's sake, and since it's going to take me a very long time to scroll, I'm going to go and just type in 10,000 cycles, 10000, and then press the respective cycle button here. We're on for 10,000 cycles. And it is a good point of reference, which I just did do, that whenever you change your burst period or your duty cycle, turn off the function generator, unplug it from the amp, and then once you have your value reset, turn the function generator back on, plug it back into your amplifier. So we can verify that that worked by changing our horizontal scaling here. If we zoom out a little bit and move our cursors, we're going to be on for about 10 milliseconds, which for the burst period here, 1% of 1 second is exactly 10 milliseconds. So we know that our parameter has changed. So that is in general how to change the main parameters on the function generator. Frequency is changed the similar way to amplitude. To change your duty cycle, you either have gated, which is a 50% duty cycle based on your whatever burst period you have, and if you want to change to some percentage of that, you'll go to this cycles, and you'll specify the total number of cycles that gets you to a percentage. Similarly, if you wanted to say change your burst period, you would click the burst period button right here, and then you can change your dial as well. So let's change this to 2 seconds, plug this back in, and as you can see here, we still have a 1% duty cycle. We're on for 10 milliseconds, but if we zoom way out, let this load for a second, more, so we can see our full burst period. We're going to scroll. It's being stinky. Regardless though, now we have a 2-second burst period, which when you scroll really far out on this, it gets a little finicky. We'll come back in so we can look more closely at our waveform. Okay, so in general, those are the two important parameters that you may, or the two main things that you'll be dealing with on the function generator. Some more niche aspects of this When you want to, sometimes the function generator needs to be turned on and off in a specific manner for whether that be a cycling or to use other functions for it. And that is primarily controlled via the computer that is in the experimental room, via a MATLAB script that plugs into the serial port on the back side and basically just sends an on-off, tells the function generator to turn on and off and uses whatever parameters are set to the screen. You can also change what triggers the output of your channel by this source value here under burst. Right now it's set to internal. It triggers itself every 1 second, but you can also do external and manual. Manual is exactly how it sounds. You would have to manually trigger this every second. Or external, on the back there are counter inputs of BNC that you can be triggered by, say, channel 2 or by some other external value here, but for the most part we use the internal trigger. Some other values on this screen are the load. So we're set to a 50 ohm load right here, which can be changed under our utility button here. So it's 50 ohms, you get to output setup, load, and we either have high Z, which is 1 mega ohm, or 50 ohms. We use 50 ohms because that is the impedance match to the amplifier, and we want to match those up so that we don't get any losses. So that value doesn't need to change, but is a good thing to know what it means. So we'll go back. And any other aspects that are still of question can be referred to the manual of this model of function generator.